When a crisis strikes a business, the managerial instinct is almost always geared toward immediate pain relief. We naturally seek the fastest available intervention to stop the bleeding, an approach commonly known as the quick fix. Consider a leaking roof inside of a large manufacturing plant. Rainwater drops steadily onto a critical piece of machinery. The immediate instinctual response is to place a bucket under the leak, or throw a plastic tarp over the machine. The symptom, water hitting the equipment, is neutralized. Operations resume. But the fractured tile on the roof remains broken. When the next heavy storm hits, the bucket overflows, the tarp gives way, and the machinery is destroyed anyway. The localized solution merely masked a structural degradation. Breaking this cycle requires a shift in discipline, embodying the methodology of a shindanshi, or a business diagnostician. While the reactive manager acts as a perpetual firefighter, exhausted by suppressing localized flare-ups, the diagnostician bypasses the bucket, climbs onto the roof, and maps exactly why the tile cracked in the first place. Isolating these structural defects requires a systematic protocol. It operates in two phases. First, expanding outward to capture all variables, then drilling downward to isolate the core mechanical failure. This protocol is executed using two highly specific diagnostic tools operating in tandem: the fishbone diagram to map out the horizontal variables, and the 5 whys methodology to drill vertically into the system's logic. Recurring operational failures are not random streaks of bad luck. They are the mathematical result of applying superficial behavioral patches to underlying mechanical flaws. We can observe this protocol in action through the case of Siam Woodcraft, a B2B furniture assembly plant experiencing a severe operational breakdown. The presenting symptom is a severe logistical bottleneck. For 3 consecutive months, the factory has missed its critical delivery deadlines. A major international client is threatening to terminate their contract. The company's primary revenue stream is at immediate risk of collapse. The resulting internal pressure triggers a predictable organizational response. Different departments begin aggressively pointing fingers. The sales department blames the production managers, demanding to know why the assembly line is moving at a fraction of its normal speed. In response, the production managers deflect the responsibility downwards. They accuse the assembly floor workers of taking excessive breaks and deliberately slowing down output. Accepting employee laziness as the final answer is a diagnostic failure. Terminating the investigation at the point of blame guarantees the exact same delays will happen with the next set of employees. To bypass this cycle of blame, the diagnostician initiates Phase 1, divergent mapping. This forces management to zoom out and catalog the entire operational landscape before drawing any conclusions. This is the Ishikawa, or fishbone diagram. A main horizontal spine leads directly to the core symptom, in this case, production delays. The mapping must follow the MISI principle: mutually exclusive, collectively exhaustive. Every conceivable variable must be categorized without overlap, ensuring no potential cause is overlooked. To achieve this exhaustive state, variables are sorted into the 4M1E framework. The branches extend outward: man, machine, material, method, and environment. Under man, the team lists hypotheses like a lack of training or worker fatigue. Under machine, they question if the pneumatic nail guns are leaking air or if clamping tools are failing. For method, the investigation considers overly complex assembly procedures. Environment prompts questions about extreme factory heat slowing down manual labor. Finally, material examines the physical inputs. Is the wood supply warped, or is the adhesive failing to bind? By laying out these variables, divergent mapping strips away office politics. Accusations are converted into cold, testable hypotheses. Phase 2 applies the Gemba filter. Boardroom speculation has zero diagnostic value unless verified at the Gemba, the actual physical location where the work is performed. Upon observing the assembly line, the reality becomes obvious. The workers are not lazy. They are standing idle because they physically cannot proceed until the wood glue on the previous component has dried. The Gemba filter acts as a scalpel. Theories regarding worker motivation, failing tools, assembly manuals, and factory temperature are immediately discarded. Only a single active variable survives the physical reality check: the material input of the glue. With the target isolated, the diagnostician begins Phase 3. This utilizes the 5 whys methodology to penetrate the surface-level symptom. We ask the first why. Why is the glue drying slowly? The investigation reveals a switch to a cheaper water-based brand. Why was the switch made? 3 months ago, the procurement department mandated the new supplier. Why did they mandate it? Because the water-based glue was 30% cheaper per barrel. Why did procurement prioritize a localized material cost without analyzing the impact on factory production speed? Because they operated in a silo and never consulted the assembly managers prior to the purchase. Finally, we ask the fifth why. Why did procurement make an isolated decision focused solely on cheap materials? The answer is structural. The procurement manager's annual KPI strictly required a 10% reduction in raw material costs. A localized, seemingly rational financial incentive engineered a cascading, catastrophic mechanical bottleneck on the production line. Review the initial instinct of the management team. If the CEO had punished or fired the assembly line workers, delivery times would not have improved by a single minute. The new workers would still be standing around, waiting for cheap glue to dry. The only valid countermeasure is a structural change. The procurement KPI must be recalibrated to align with overall factory throughput, and the supply chain must revert to the fast-drying adhesive. This list compares the failure states of a superficial investigation against the systemic rigor of true root cause analysis. If your analysis terminates by assigning blame to an individual, the investigation has failed. Rigorous analysis always terminates by exposing a flawed system or policy. If your proposed solution relies on issuing a memo or telling employees to be careful, you are treating a symptom. Systemic rigor demands poke a yoke, mechanical or software safeguards that make the error impossible to replicate. This brings us to the absolute unbreakable rule of organizational diagnostics. Human error is never a root cause. It is simply another symptom on the surface. When an employee makes a mistake, the investigator does not stop to punish them. They ask why the operational environment allowed that error to occur without safeguards. Optimizing a business requires a complete departure from the primitive culture of blame. It demands the implementation of systemic engineering, where every localized failure is treated as an opportunity to reinforce the structural integrity of the entire machine.